Hi guys, in this video we'll be making a character selection screen for the Zephyria RPG, and today one of my students joins me to help me do that. Hi Jack.
Hey.
So what I'm going to do is I'll give you a task which you can start thinking about, and then I'll start building some basic elements of that task. So the idea is that because we have three different types of characters, I should be able to find them here somewhere. Character, there we go. So at the start, the player starts with character class novice, and then as they progress through the game, they're able to then upgrade to warrior, scout, or mage. And the character selection screen, I'm thinking if we have a circle in the middle somewhere, and then a rectangle here which contains all the information, like this could say something like warrior, and then an image somewhere here, and then some stuff in terms of like stats, abilities, and so on. And then if we do this kind of circular thing, and we have three more character sort of almost like widgets. So one is going to be warrior, mage, and scout. And then depending on which one the user clicks to read more, this circle should spin in order to move the class that the user picked to this middle space. Is that somewhat clear?
Mm-hmm. Yeah.
Yep, cool. So start thinking about, I think the main problem is going to be angles, like figuring out how to rotate the thing. Because, I mean, the three things are like straightforward. You have a 120 degrees angle between them, right? Because there are three things in a circle. But positioning...
Is it always going to be free?
No, which means we're going to divide by the number of things. So it's 360 degrees divided by some kind of an x. And that x is going to be the number of, think of them as cards, I guess, because they will be drawn as cards, like Magic the Gathering type stuff.
Yeah. Okay. So you need some sort of pivot that they're essentially mounted to.
Yeah, I mean, implementation-wise, we're going to be probably rotating from the center, which means you need to figure out the position of that thing. Well, I guess you could draw a vector to the circle, figure out which point it's going to intersect with, and then kind of offset. What do you think?
By offset, do you mean the actual card? Because
yeah.
I'm guessing that they're top left anchored at the moment, so you need to offset it so that they're centered.
Mm-hmm. Yeah, that sounds about right. And meanwhile, I need to get started on building the UI for this, so that you can also see how it kind of is brought to life, sort of thing.
Mm-hmm.
It's going to be a subscene, so we'll go with char select subscene.
I'm just going to grab a paper and pen.
Yeah, it's probably going to be useful.
Okay.
So increase the font a bit so that's clearer. 24. Yeah.
Massive.
I mean, we don't know what the audience will use in order to watch this, so it's better to stay on the safe side and just go with something big. Char select subscene.
First, you've got the screen, right? So you've got to work out where the center is, which is pretty arbitrary.
Yeah. Let me actually draw a rectangle, and then this will be our starting point. So if I have something like... Well, first of all, we need to know how big the game is. The game is 1700 in terms of width. So let's go half of that. Application width divide by 2, and for height divide by 2, so basically half of the application. Let's try that. So when I press, let's go for, when I press Y, we're going to see this new screen. Well, right, so that's what we have at the moment, just black rectangle. I'm going to position it in the center. But for now,
okay, yep.
That's our, like, this thing, like the white rectangle that you can see here. So
yep.
Inside that rectangle, I'm going to place a circle in the middle, and then we can start thinking.
Okay. I'm just drawing it out.
Mm-hmm.
Then I'll try and explain my thought process. Okay, well, one of the first things I need to know is, obviously, so we need the radius. Then need to... In this engine is positive rotation. Does it go clockwise or anti-clockwise?
Positive rotation is clockwise.
Okay. Is it measured in degrees or radians?
Degrees are much easier.
Okay. So my initial thoughts are about the anchoring of the card to the circle, which is, are we wanting the center of the card to follow essentially not an actual spline, but if you understand what I mean, like if we treat the circle as a spline.
Well, can you see this dot over here?
Yeah.
I'm thinking that could be a good starting point for the center. I don't know. Because that dot is easily computable, right? We just take the center and then we offset by the vector.
Sure. Yeah.
And then that vector is computable from the angle, because this is our 0-degree angle, which means this is 90 degrees. To the left, it would be 90 plus 120, because the difference between these two cards is 120.
Okay.
I think so. We'll see how it goes, but I'll just draw a circle of some arbitrary radius. Let's go with 300. I don't know how big that's going to be. And then for the center, I'm going to use, I guess, these two values.
So when we do get to the position of the card, the first thing will be you have to offset the first one.
I think so, yeah.
Anyway,
because I know the center one is easy. Okay, the circle is too big, and there's something wrong with my rectangle. Get application height. Maybe let's do that. Oh, I need to divide by 2 as well. And the circle, let's make it 150. Okay, the rectangle is too small now, but I'll make it a third of the height. And then the circle needs to be somewhere there, I guess. This is a third of the height. Oh, it's center X, center Y, then radius. I got the order of parameters wrong, which is why it's doing that. and then I need to take into account the offset of that thing. So it's actually background width and background height. So now it should be dead in the center.
Our circle's drawn from the center then?
These are the center coordinates, yes.
Okay.
We can draw it from top left or from the center, but I think because we're dealing with the center.
Oh, center makes more sense.
Yeah. So this is circle. Just thinking what kind of color we want for the circle. Let's give it a different stroke color. Something like white, so it's clearly visible. Right, so this is what we have.
Okay.
And then
so the next
I can make it bigger.
Sure.
Because, you know, if you look at the entire screen, we can occupy more space, right?
Mm-hmm. I mean, obviously we want to make this independent of size anyway, so we should be able to adjust.
Well, I'm using the size using a variable, as in I'm getting the size dynamically. So here we don't know what the size is, but we can still make the values relative to that size.
Mm. So just so I know, what I'm presuming there's a vector library.
Yeah, we've got all the stuff we need in terms of maths. Cool. So yeah, let's go with that, and then I'll sorry.
So this should be fairly simple.
Well, hopefully. I kind of have an idea, but I'm not quite sure yet. So we've got this. I'm going to fix the rectangle size later, but for now, let's go with this as a kind of base.
Okay.
So we've got this circle. I think it's big enough. So if we place one more rectangle over here, which should be easy.
Mm-hmm.
And then
is that going to be parented to the circle as well?
The whole thing is parented to an invisible root node.
Okay.
But it will be in the same sort of coordinate system. So let's go with... So how do we get to the center now? I want this center. I want the center of this card.
Center of that card. So you're talking about the pivot point that's along the...
this one.
Yeah, as in, so you want it along the circle, though.
Yeah.
So we need to, first of all, get the coordinate that's at 0, so that'd be to the right. Correct?
Yeah. Oh, you mean 0 degrees, yeah.
Yeah, and then we need to rotate that vector by 90 degrees.
Yeah, actually, we can, because it's already 0, how about we use 90 degrees vector and just add there? Because I'm thinking this point is always going to be there, like regardless of how many items we have. We have one item, we just draw it there. We have 2 items, we draw the other one at 180 degrees.
Okay, yeah.
If we have 3 items, then the difference is 120, but the first item will always be here. In which case that simplifies it, because we just take the 90 degree...
and then just add from there.
Yeah, so the vector is essentially just that, 0 and 1. Or the unit vector is. And then we just multiply it by the radius.
Mm-hmm.
Where's our radius? Circle radius. And that's our vector. So we need now to add, first point is center of the circle. then add vector. And then we need a card. Just quickly create a class card so we can use it. It's called rectangle. We're going to have lots of rectangles. 200 and 350. Yeah, that'll do. And then we'll just set fill to something else, like color blue. And then we're going to position our new card at first point. Yep, that works, I think. Yeah, let's try that. So I think we've done the straightforward bit, which is, well, I need to offset it, but we've got the point. And then I'll just offset it by half of the width, half of the height. Now, how do we get to other points?
Well, we need to know how many points we want, and then we just need to do 360 divided by that, and then rotate
let's just assume there's going to be 3 at least for the first implementation, and then we'll just generalize this.
Okay, so do you just have a function that you can just put 120 into?
What do you want the function to do? Do you want to get...
Well,
we need to get the vectors, right?
Yeah, so you've got that unit vector, haven't you? So we need to rotate that, and then multiply that by the radius.
Yeah. Sounds good. So we got our vector. Actually, I'm going to do it slightly different, but the same logic. Instead of rotating the vector, we're going to rotate the angle and then get the vector.
So do you want to build this hard-coded for now, and then we could possibly turn it into...
Yep, I'm going to hard-code it for now, and then I'm going to refactor it a little bit later.
Cool.
So we have 90 degrees plus 120, and then I'll add 120 is hard-coded. So 90 will always be 90 because we decided that the first card will always be there. But 120 is hard-coded, and it's equal to number of items divided by, actually no, it's the other way around, right? It's 360.
Yeah, it's 360 divided by.
Yeah. So that gives us second point. And then we just add a card at that second point. Oh, I need to offset it, so it's minus 100, which is half of that, and minus 175. And then just do the same. So that should give us the second card. Oh, I need to still get the vector and then do the transformation. Because that's a unit vector. It doesn't do anything.
Hang on, I'm having a look. I think I might have missed something.
No, everything's right. I just missed these two.
Ah.
Because I need to add this to the vector. Because vector is not the location, and then but we need location. Yeah, just convert it to. Yeah, that should do it. That should give us the correct second point. And then from there, we can figure out the third point as well. Oops. So the first one is right. What happened to the... So we got the point, which is center. We added the 90 degrees plus 120, which gives us 210.
And then where are you multiplying that by the radius?
Oh, you're right. Yeah. So this is still a unit vector. We need to multiply that by the radius. Nice.
Hey!
So now we need to rotate it, because this one's fine, but this one is going to be rotated, I guess, that way. So this is down, like I'm drawing the down arrow, because when it's rotated back, this is what it's going to look like. So it needs to rotate that way, like that way, by, oh, we know by what value. It's 120,
yeah, you've got
right?
the rotation.
It's 120, isn't it?
Yeah, should be. Well, hang on, actually no. It'll be more, because obviously 0.
Oh, it's going to be 210. Yeah,
it's
going to
210.
210.
It won't be 210, I don't think, because down is technically our 0, because...
No, down, well, we're going to be drawing in sort of games coordinates, not in ours. So down is 90.
Yeah, but...
Oh, yeah, I see what you mean.
Rotation of it. Yeah, you see what I mean.
Yeah, yeah. So this is 0 degrees. Okay, this is where we're looking at. In which case it is 120.
Yeah, it would. Yeah, you're right.
Yeah.
120.
Yeah, cool. So 120, it's that, but at which pivot point are we rotating it? Or do we just rotate it from the center and then we shift it?
Ah. See, so you'd want to rotate it before you offset it, right? Or
no? Yeah, I think that's going to be the tricky part.
Right, okay. Well, it depends on what rotations you have available. So, do you just want to try rotating it by 120 for now, and then we can sort out the offsetting?
Yeah. Let's do 120 rotation first. So this is the second card. It rotate 120.
That's easy.
Yeah, it's actually JavaFX. Okay, I think that's perfect. I think that's it.
Done.
Okay, that was a lot easier than I thought. Because by default, it rotates from the center anyway. Because that's not FXGL's one, this is JavaFX's rotation. So that's pretty cool. I think the rectangles need to be slightly kind of more wide and possibly smaller in height. But apart from that...
If you make them wider, they might overlap.
That's true. But then I can reduce the height. So
yeah.
The height is something like 300, and then maybe 230, 240. I need to stop hard coding these values because it's going to be a nightmare to change all of these values. But I'll do for now. And then let's add a third one now. So this is going to be our third point. We're still doing that, and then we'll just add 120 one more time. Okay. What's the rotation on this one?
Is it 240?
Yeah. So we can already see how to generalize this. The same values seem to appear. Yep, that looks good.
Yay.
Okay, so we've done the static bit. Now on to the dynamic one, because we want to be able to click this one like that, and it rotates the entire thing.
Okay.
So here's the center, I think we can rotate the entire kind of circle, but we need to, like you said, parent it to something. Because currently, if I rotate the thing, it's going to rotate the rectangle as well, like the big one.
Yeah. I mean, you could parent it to something. I mean, we do actually have everything there.
Yeah, I just need another invisible root.
Well, I was going to say, we've already got the mathematics laid out so that you could just change the values if we just generalize the values, or as you say, kind of group them together.
Yeah, but I'm currently thinking about because I don't want to rotate them individually. I want to rotate the entire thing.
Okay.
So if we have this, but instead of adding a child, we're going to add it to this root node. And then everything just gets added to here, apart from the background. So the circle is going to be there.
My inner C programmer is crying. It always throws me off when I see a language without semicolons everywhere.
Yeah. I mean, Kotlin's nice. It's much more productive compared to Java.
I need to get into it more. I'm seeing you do this. It's so quick.
It is, yeah. Compared to C++, definitely. But even compared to Java, because in Java it's just so verbose.
What would you say it is that Kotlin does that reduces that?
I think it just adds more functionality, and as in more functions that allow us to do stuff, and some kind of syntactic sugar, I guess.
Okay.
And then if we add child root, that should do it, because by default it's placed at 0, 0, so it should be perfectly aligned. Yep, nice. No changes visually, but conceptually,
yeah,
this entire thing, circle and the 3 rectangles, are one, which means we can rotate it.
So could you just rotate it by an arbitrary amount?
I can just rotate the root, but I just need to rotate it at center of the circle. Yeah, that's nice. So suppose we click on this second item. There's got to be on click or something. Set on mouse clicked. There we go. We're going to rotate the root.
I can see a class forming here. I can see a class forming here.
Yeah, potentially. So how many degrees do we rotate it by? So if I'm clicking on the second thing, which is that one, it needs to go back 120, right?
Yeah.
So it's rotation of this thing.
Wait, which one are you clicking on?
That one.
Second one, so it'd be minus 120.
Yeah, because it needs to, because we're rotating this kind of, this invisible root around it, which needs to go minus 120 because it is counterclockwise. Yep. So it's minus this thing, because we don't know how many degrees this is going to be in the kind of long term.
Yeah.
But minus. Let's try that. Actually, we won't see any difference, I don't think, because they're exactly the same, right?
Need to change the
well, it did change something. I guess I need to say explicitly that transforms pivot point, because I don't think it knows where the center is now. Angle, pivot X, pivot Y. Yep, that's good. So let's try that. Maybe add something here, like another color. So we can distinguish.
I mean, you could actually eventually change that to be the class, and then it.
Yeah, I
has a
mean,
color
this
based
whole
on
thing
class.
is going to change. But for now, I just need something done quickly. So
Oh, yeah.
the first one, let's go blue, and then second one is red. And then the third one is, I don't know, green. So if I press on the second one, it should...
DRG.
Yeah. Nice.
Awesome. So what happens if you click on
now
it
we
again?
need to animate this, because you know, it's not as cool if it's not animated.
Can you just can you click on the red one again?
Yeah, because it's still clickable.
Yeah.
Which means, well, I'll fix that later. The great thing about this, it works. It allows us to move around. Okay.
Awesome.
So we're almost 90% there, I think. Last thing is, I want this thing to actually rotate like visually. Not immediately snap, but kind of do an animation. We know that this needs to be done here somewhere. So how about, and the good news is we have a really nice animation library here.
I was about to ask.
Yeah. So if I use this, and then we're going to rotate root from, I guess, 0 degrees to minus card rotate, and then we need the origin point, which is that one, which is the center of the circle. By default, it's 1 second, so I'm hoping this is going to work. Nice. Oh, wow. It does the spinny thing. It probably lags on your screen.
Oh, no, it's actually quite smooth.
That's pretty good. All right, and then just as a final addition, we can add an interpolator in there. Interpolators, let's go for bounce. You should quite like bounce. Ease out, and then increase duration to 2 seconds, so it's clearly visible. It's pretty cool, right?
Wow.
And then we can add actual text and then stuff later on, but I'm quite pleased with what we've got so far.
This has happened much quicker than I thought it would.
Well, FXGL is mature now to support a lot of different things. So all we needed was just to figure out how to position these things, and then the rest was...
I was genuinely expecting to have to do like vector mathematics on that.
Well, we did. I mean, all of that is vector maths. It's just we need to figure out what we're trying to do, and that's the hardest bit usually. Because the rest is like, you know, ask the engine to do this, ask the engine to do that, and you know, maths is not important in terms of how. It's more important in terms of what it is that we're trying to achieve and why we're doing it. The how is usually done by the engine. Okay, so in this video we made a character selection screen, which I'm going to then populate with actual in-game text and then kind of refactor a bit of code in here. But that was great. Thank you very much for your help, Jack.
Oh, thanks for having me.
Yeah, and in the future, if you're interested, we might do something similar, whether in this game or in some other games.
Awesome.
Yep, cool. And thank you, the audience, for watching. And I'll see you guys in the next video.